Good morning, everyone. Today, I would like to talk about how to add new values to memory subsystems through CXL. So CXL is opening up a new gateway toward efficient use of computing, acceleration, and memory resources, as shown in this view graph. As you can see, the CXL allows to interconnect the different types of XPUs, including CPU, NPU, DPU, GPU, and FPGA. And it also allows to connect this server node externally to computing acceleration memory pools, as well as servers in remote racks. And also, as you can see here, it allows adding CXL memory to a CPU directly. So this will be one example of adding a Type 3 device. In today's presentation, I would like to focus mostly on this, around this memory. So CXL creates many new additional opportunities in memory subsystems beyond what is possible today in existing server platforms. In today's presentation, I would like to focus on 4 key values as shown here. The first value is memory bandwidth and capacity expansion. The second value is memory media differentiation. The third one is control differentiation. And finally, the first one would be memory as a service, or what we are calling MAS. So I will explain more details about what I mean by this. So in the following slides, I'm going to explain one by one what each of these key values means. And the first item will be about this expanding memory capacity and bandwidth. But before I explain that, I would like to explain to you about what the current limitations are in existing server platforms. So increase in SoC core count requires continuous increase in memory bandwidth and capacity, as shown in this view graph here. The graph on the left-hand side shows you how the bandwidth requirement and bandwidth provisioning capability of the system grows over the years, or expected to grow over the years. And as you can see, you already start to see this big gap between the requirement and what the system can deliver. And this is mainly because of 2 reasons. One is because the number of channels now gets limited due to the form factor limitation of the server chassis. So it will go up probably to 12 channels, and even 16 channels is still doubtful. And the second reason is because now the data rate of the I/O itself on the DIMM is becoming so high. As you can see there, you see these blue lines on the left-hand side, 9.6 and 11.2, that falls into the DDR6 bit rate. And already a big challenge is expected how to achieve this high data rate. On the right-hand side, I'm showing the memory capacity requirement over the years. And as you can see, for different workloads shown here, for memory-intensive workload, general-purpose workload, and compute-intensive workload, you can see that this requirement is growing drastically, even though there is some differences in the slow rate depending on the workloads, but it will continue to grow. But if you look at this, one of those horizontal lines, if you look at the second from the top, assuming that we have a 32 gigabit DRAM monodie, which does not exist today, and we can build a maximum of 128 gigabyte with a single die package. And assume we adopt this in 12 channels, and we have 1 DIMM per channel. Even if you do have that, then you still won't be able to satisfy the capacity requirements in bands. But now, by introducing CXL memories, we can close this gap in bandwidth and capacity. As shown in the graph on the left-hand side, you can see that as we add more number of bandwidth memory expansion modules, we can extend the bandwidth further, as shown here. On the other hand, on the right-hand side, we can also increase the capacity through CXL. So instead of adding more memories to the channels or to more number of DIMMs, which is becoming more difficult now, as I explained, now CXL opens up the opportunity to add more capacity to to this CXL channel, as shown here. The second key value I would like to talk about is the memory media differentiation. So this picture here shows you a CPU with 2 tiers of memory. The one on the left-hand side, that's a traditional standard DIMMs. It can be RDIMM and LRDIMM in servers. And also, as you can see, since this is a standard interface, you can, it's a DDR interface is adopted here. And as you're well aware of, this is memory aware and it's deterministic. In other words, this is very closely coupled to the CPU. It needs to be co-designed from the beginning. On the other hand, CXL interface is a memory agnostic and non-deterministic protocol, meaning that it now allows decoupling of memory media from the CPU, as shown here. By doing this, now we can afford to provide different memory media to our users. We can either choose to have standard memories, such as DDR5, or we can have even custom memory media as needed. And as such, different memory media can provide different performance, capacity, and power design trade-offs. The third key value is control differentiation. The difference between the first tier memory and the second tier memory shown here is that now we have a control in it. So now this allows to integrate some special features into our controller which can add more values. For some examples of features that we can add is enhanced RAS, such as ECC, post-package repair, and error check and scrub. Or we can integrate security functions or low power functions. Computation processing and acceleration features can be added as well. Let me show one example out of them, shown on the right-hand side. So we can, for example, choose to integrate a computation engine, which is shown here as CMS engine, Computation Memory Solution Engine. So by doing local computation, we can prevent data from moving back and forth between the CPU and the memory. So all the computation will happen locally. Thereby, we can increase the power efficiency, and we can also increase performance because all the computation takes place locally. Now, this is the fourth key value that I would like to talk about, which I'm calling here memory as a service. So this will be applicable only when the infrastructure and ecosystem is ready for memory pooling. So I would like to explain this concept from 2 different aspects. One is that variable memory capacity can be effectively allocated with a memory pool to different XPUs through memory virtualization. Though this figure here shows you different types of memory hierarchies. So you see here the HBM, which is in-package memory, and there is a DDR main memory, and you can also have a CXL memory directly attached in the same server node. Or through the CXL fabric, you can attach different disaggregated memory pools. This memory can be basically shared by all of these XPUs as needed. And the second aspect is that CXL allows building composable, scalable rack-scale memory pool appliances, which can be populated with different types of memory media. So as highlighted here in different colors, green, blue, and orange, based on the user's choice, we could provide one with one type of memory, the other one with different types of memory. So now this gives us some freedom to provide different types of memory pool appliances. So far, I have talked about the key values. In the following few slides, I would like to talk about our future path and plans and future visions in CXL. So we are planning to start with CXL memory market enabling, followed by market expansion and value addition. So this is described here as stage 1, 2, 3. So I would say we are currently at the ecosystem enabling stage. So at this stage, even though we know that CXL is going to be a game changer in the future in servers, but still there are many uncertainties about what the market volume is going to be. And also, we are unsure how exactly it's going to be used. So there can be so many different use cases. But in order to do that, you would need actual samples, a real silicon sample. And we are very proactively willing to and moving towards providing this kind of solutions. So once this ecosystem is enabled, then the market will grow and the market will expand. And once it's expanded, this gives us more opportunities to introduce diverse type of different memory solutions. So I won't go through all of the details line by line, but I would like to mention that the first product is planned to be with a standard DDR5 DRAMs, and followed by products with new value-add features. And this is still to be defined further through close collaboration with ecosystem partners and customers. So in stage 2 and 3, this could be memories optimized for better TCO, and this needs to be further defined in the future. Now we are envisioning 4 different types of CXL memory solution for different use cases. The first CXL memory will be bandwidth memory expansion, and what we are calling here BME. The second type is CXL CME, or capacity memory expansion. The third type is CXL MPS, memory pooling solution. And the final one is CXL CMS, a computational memory solution. So if you look about these solutions, so first CXL memory will be bandwidth expansion, as I explained, and it will be based on DDR5 memory. So this will go in hand as with the ecosystem enabling stage, which I just explained before. In one of the differences between this BME and CME is that BME is a memory expansion without tiering. So in other words, from the SoC point of view, it's kind of regarded as a kind of flat memory. On the other hand, in case of CME, it's a memory expansion with tiering, which means now the software has to be aware that it has a second tier. And to some extent, this allows the second tier to hide behind the first tier, and thereby the second tier can have a slightly a lower bandwidth and longer latency. And then the third one, the MPS, memory pooling solution, this will be only meaningful when the infrastructure and ecosystem for memory pooling is ready. But once it's there, our vision is to optimize memory media and module form factor specifically for pooling solutions. And finally, regarding CMS, so with growth in AI and data analytics applications, we believe that CMS can be another differentiating product, which is actually, I would say, is closer to an accelerator than being a memory. So by providing these so many different solutions, we hope that this will contribute to building the future ecosystem of CXLs. So along the lines of the plans and future visions I explained, I would like to introduce our first CXL memory. And I would like to argue that it's now ready for takeoff. So even though the theme of this workshop is that it's getting ready to take off, but actually I have brought the actual sample that we actually recently announced. Actually, it was announced yesterday. So, yeah, thank you. So this is a CXL BME device. It's a 96 gigabyte, and it's integrated with cost-effective single-die packaged DRAMs. So this is a DDR5 class bandwidth, provides such bandwidth because this is based on DDR5 DRAMs, and thereby it provides DDR5 class latency within 1 NUMA hop, and it's outperforming in bandwidth per dollar and bandwidth per power compared to 3D solution, which is TSV-based. So if I may explain some more details through this figure here. So it has total number of 40 DRAMs integrated in this module. And this is E3.S form factor and 2T width. This provides support CXL 2.0 on PCI Gen 5 8-lane. And this is architecture perspective. This is 2 rank by 4. So this is very similar like a general or traditional DDR5 single channel. So it has a 1 DDR5 channel, 80 bits, and it's 2 rank by 4. So it will be similar to 2 DIMMs per channel configuration. And this is a single die package by 4 packages. And this is 24 gigabit DDR5 die. As you may know, so 4 gigabit is the most advanced capacity that we have today in the DRAM industry. And the bandwidth will be between 30 gigabyte per second and 40 gigabyte per second, depending whether it's a random workload or a sequential workload. So since it's very difficult to see this sample from there, so I've also captured one picture from our announcement yesterday. As I mentioned, this is 96 gigabyte E3.S module and with cost-effective single die packages. This is based on DDR5 24 gigabit DRAM. And I would like to emphasize that this is with the most advanced 1A process technology. So as you may know, 1A process technology is the most advanced DRAM process available today in the DRAM industry. Together with this CXL module, we have also developed and we have also announced development of HM SDK, which stands for Heterogeneous Memory Software Development Kit. So by combining this CXL memory expansion solution or device with this HM SDK software solution, we are able to effectively utilize this device to increase the bandwidth and increase the performance, as shown on the right-hand side. So one unique feature of this HM SDK is that it supports capacity-aware placement and also bandwidth-aware interleaving. As shown on the right-hand side on the top figure, you can see the effect of this bandwidth-aware interleaving. Compared to the conventional case, you can see the bandwidth increases by 50%. And the performance is increased by 34%. And we are planning to make this software available starting from Q4. So we actually have a CXL memory system demo here at FMS at SK Hynix booth 509. And we would like to welcome you to stop by and see our demos here. So besides other memory displays, we have 2 specific demos on CXL. The first one shown on the left-hand side is what I just explained. It's how the bandwidth-aware interleaving improves the performance. That's one demo. The one on the right-hand side is related more to memory pooling. So this shows you some demo running real time. It shows you how applications are basically allocated differently depending on the usage cases. Before I conclude my talk, I would like to mention that building this CXL memory ecosystem cannot be done alone, and close collaboration with all CXL ecosystem partners across the entire industry, entire system hierarchy is essential for successful launch of future CXL products. And we are very committed to be a key player in building such ecosystem by delivering differentiated value-added memory products to the industry. And this will be basically all of you who are here today. We hope that we can build this ecosystem together. I'll quickly summarize my talk. So I talked about the 4 key values, which is capacity and memory bandwidth expansion, memory differentiation, control differentiation, and memory as a service. So we are very excited and committed to be able to contribute to the CXL ecosystem by delivering differentiated CXL memory solutions such as BME, CME, MPS, and CMS. And as I just showed you our sample here, we are very pleased to be able to announce our first sample, which is based on 24 gigabit 1A nanometer process. And I would like to emphasize that we hope that this will help to build the ecosystem stronger. And we'd like to mention that this is just the beginning toward providing more valuable, scalable memory solutions to the entire industry in the future. Thank you for your attention. Any questions? Yes, please.
Okay. Thank you very much for interesting presentation.
Mm-hmm.
And I have two questions. So first one is, so you mentioned that you take a 3-stage. First one is using the current DDR solution, and so move to the stage 2 and stage 3.
Right.
And then, so do you have any kind of the time scale for this kind of the step?
Oh, it's hard to say, but I think to some extent we can say, because we know how the CXL spec is going to evolve. So we believe the first bandwidth memory expansion solution, which is DDR5 based, that will persist for a while. And it will take a while until you can basically, you will be ready for the differentiated kind of some new value-added features. And developing a new controller, as you know, takes a lot of time, at least 2 years, 2 to 3 years. And validating that and all that will take, I think, at least 3 to 4 years. So I would say, yeah, you would have to wait around that time before you see those kind of samples to appear.
Okay, thank you. And the second one is that, so you also mentioned the kind of the differentiation of the memory. And so now, so your solution is based on the DRAM. But so do you have a plan to introduce non-volatile memory, such as our NAND flash or CXL NAND flash, or in the future? Do you have a plan?
Yeah, so we don't have a very official plan. It's not a POR, but we are internally researching many different kind of memory solutions. And as you mentioned, non-volatile memory could be one direction, and having this non-volatility in place could provide actually other benefits, as PCM, for example, has been available in the industry. But there can be also other memory solutions, but we are still at the researching stage. But yes, we are looking into that as well.